This question is about entropy. Consider a reaction between solid ammonium carbonate and pure ethanoic acid. What do you observe as this reaction occur? What observe means what we'll see. So we'll see bubbles because the carbon dioxide gas is given off. So whenever a gas is given off, we'll see phase, bubbles, effervescence. Then predict the sign of entropy of a system and justify your answer. No calculation. Entropy, as the number of the particle increases, the entropy increase. And as the state change, like example, solid to liquid or liquid to gas, entropy also increase. So you can see 1 plus 2, 3 particles are there for reactant, and 2, 1, so 4 particles for a product. So 3 particles for reactant, 4, so number of particle increase, entropy increases. As well as the state changes, like initially it was solid and liquid, but now solid, liquid and gas. That's why the entropy also increase. Then you have to use a data booklet, use a standard molar entropy on page 2, 3 and 29 of a data booklet to calculate a standard molar entropy of a system. Entropy of a system, it is a product minus reactant. So using a data booklet, you have to use a data booklet. So entropy of a system will be the product minus the reactant. So data booklet, just a minute. So page number 2, 3 and 29. Here you can see the entropies are given for different substances, for different elements, as well as so 2, 3 you will find here and 29. On page 29 you can find for SF6, which is the total entropy is 291.7. And for reactants, the element is already given on page 2 and 3. So it will be the product minus the reactant. So if you find for reactant, that is 331.8 plus 3 into, because you can see here 3 multiple for fluorine. The molar entropy for fluorine is given, but how many are there? As you can see, this page 2. For fluorine, the number of atoms, like for here it is given the molar entropy, which is 158. But that is for one atom, like one particle. For if it is F2, then it will be multiplied by 2. And there are 3 molecules of fluorine, so it will be multiplied by 3 as well. Like here for this one, sulfur. This is sulfur, this one is fluorine and SF6. So for sulfur, it is 31.8. For fluorine, it is because 3 molecules and one atom is having a molar entropy of 158.6. But 2 atoms are in one molecule, so it will be twice. And for reactant, the product, that is 291, one molecule is there, 291.7. And then to get the entropy change for a system, product minus reactant, so 291.7 minus the reactant 31.8 plus 3 into 2 into 158.6. So this will give us negative entropy, means the entropy will decrease, and it, as you can see clearly, the entropy is decreasing. because like solid, gas, and few particles are there. Number of the particle 1 plus 3, 4 are there, but here we have only one molecule. So we'll get a negative answer for entropy. And they already give you for entropy for half fluorine molecule 158. So one fluorine molecule will be twice of this. That's why we did twice. Then entropy, using the value of a standard enthalpy change of formation given above to calculate the entropy change of surrounding. So enthalpy change is given minus 1209 kilojoule per mole. So that is in kilojoule per mole, and this will be in joule per mole. So we have to convert both of them. It should be in the same unit. Like here, if molar entropies are given in joule per mole per Kelvin, so this should also be in the same unit because we have to add them at the last. So entropy change of a surrounding minus delta H by T. That will give us entropy for a surrounding. So minus, this was 1209 kilojoules. So we have to convert into joule. So we'll multiply by 1000. So now this will be joule. And temperature, that is 25 degrees centigrade or 298 Kelvin. So the final answer will be 4057 joule mole inverse Kelvin inverse. And then the total entropy is the system plus surrounding. So we will add them, we'll get the total entropy of this reaction. And what would be the effect if any increase in temperature in the total, and justify your assumption you made. So what will be the effect of increasing a temperature? As you can see, when we increase the temperature, the entropy of a surrounding decreases. So if entropy of a surrounding decrease, the sum, because entropy of a system is in total entropy system plus surrounding. So the total entropy is the entropy of a system plus entropy of surrounding. System cannot be changed. Surrounding can be changed. Surrounding is minus delta H by T. And because of reaction was exothermic, so we were getting a positive answer. So it was minus, and it was already exothermic, so minus H. So we're getting a positive answer for entropy of surrounding. But if we increase the temperature, entropy of surrounding decrease. If entropy of surrounding decrease, the sum will also decrease. Then magnesium, this is the hydration energy. Magnesium and sulfate ion hydrated. Compare the value of entropy change for dissolving these two sulfates and how they are consistent with the trend in solubility of sulfate. So when we compare, as we go down the group, the solubility of sulfate decreases. So barium sulfate is less soluble than magnesium sulfate. And what will happen, as you can see, why the solubility decreases as we go down the group. So the total entropy get because more exothermic, or it will be less positive. As you can see, this will having so as we go down the group, the solubility decrease. Why the solubility decrease? Because the total entropy is the entropy of system plus entropy of surrounding. System does not change, surrounding is minus delta H by T. So entropy of a system minus delta H by T. So for magnesium sulfate, this delta H was positive, so we were subtracting. But for barium sulfate, what will happen? The total entropy is more negative. Why the total entropy is more negative? Because this, as we know, this system, like the total entropy system plus surrounding, and surrounding is minus delta H by T. So as we go down the group, solubility is decreasing. So barium sulfate is less soluble. You can see the total entropy is more negative from the data as shown here. So if the total entropy is negative, or we can also say magnesium sulfate is total entropy is positive. So the feasibility of the reaction decreases as the entropy become negative or it is less positive. Then the value, the total entropy change at equilibrium constant R ln K, calculate the value of equilibrium constant K. So for magnesium sulfate, so total entropy value is given in the question. R is given, you divide them and take anti-log, you will get the value for K.